Okay, today we're going to go ahead and take a look at ellipses and also hyperbolas. Well, once again, just to review with conics or cones going from one point to another, if you cut it horizontal, you get a circle. A little bit of an angle, you get an ellipse. Slightly more of an angle, you get a parabola. Even a steeper angle, pretty much going up and down, you get a hyperbolic shape or hyperbola. We're going to start off with the official definition of an ellipse. An ellipse is a set of all points on a plane whose sum of the distances from the two fixed points, those two fixed points we call our foci, and on our graph here, those would be these right here, is constant. So in other words, the length of this dotted line plus the length of this dotted line always adds up to be the same length. Well, that would also be true if we went and say went to here and then to here. The length of those two blue segments would add up to be the length of the two dotted black ones. Or similarly, if we went to here and added the two red ones together, the length of the two red ones would be the same as the length of the two black ones or two blue ones all added together. So it ends up being a constant. Well, for the most part, ellipses can be written in this form here. H and K is your center, which we have up here. A is how far you go left and right from your center. B is how far you go up and down from your center. If it's elongated in the horizontal direction like we have here, we would say this is your major axis. However, if it's elongated more in the vertical direction, then the vertical part would be your major axis. Now, we also have our foci. In this particular case, our foci would be here and here. Your foci are always on the major axes. Whichever one is longer, the vertical or the horizontal, that's your major axis, and your foci is always on that. The distance from your center out to your focus is C. Whether you're going to the right C units or the left C units doesn't make a difference. Your equations for finding C when you know A and B are given to you down here. You'll notice there's two different ones. For the most part, you use whichever one's going to give you a value of C being a real number. Basically, whichever one of these two is bigger, the A squared or the B squared, that's what you put first. Because if you take the bigger one minus the smaller one and take your square root, you know you're going to get a real number. We also have eccentricity. That's how circular or non-circular your ellipse is. And we'll be talking about that a little bit more in the next one. Here's another way you can think of remembering your Pythagorean theorem. I'll let you go ahead and read through that in the context of this, or not the Pythagorean theorem, but the relationship of the A, B, and the C. Well, let's talk about eccentricity. Eccentricity, once again, is how circular or non-circular your ellipse is. Here, when your eccentricity is almost zero, where the value of C is really small compared to the value of A, it's almost circular. However, when your eccentricity is close to 1, where C is almost the same size as A, then it's really flat and elongated. Here is a screen that discusses the reflective property of ellipses. So you can see that yes, ellipses do have application. So you can go ahead and read through this. So let's go ahead and find our information here so we can graph our ellipse. Well, here's your given problem. Here's the general one. So we need to go ahead and work this out. We need to look at this. We have an A squared being our 9, a B squared being our 25. So we need to solve it for A and B. So we take our square roots. So A, once again, is how far you go left and right from your center. B is how far you go up and down from your center. Your center is 0, 0 because there's nothing added or subtracted from your x's. So you go 3 units to the right, 3 units to the left, and then from your center you go 5 up because B tells you how far to go up and down. And then, for the most part, you try to draw in a smooth curve going through all 4 of those points. Well, let's go ahead and find your foci. Remember, you always want to take the larger minus the smaller, so you're going to take the 25 minus the 9, and then take your square root. So your foci are going to be 4 units on your major axes. Your major axis goes up and down here. So it'll go up 4 units, down 4 units, so it'll be at 0, 4 and 0, negative 4 for your foci. Your vertices are the blue ones at the end of your major axes, so that's up and down 5 units.